This meeting is being recorded.
Sections 9.8 and 9.9 from your textbook and in the PowerPoints here are fairly short, so I will review both sections 9.8 and 9.9 in this video. So first in 9.8 we see this reaction type, the halogenation of alkynes. So halogenation, if we give excess of the halogen, will always yield a tetrahalide, right? Two equivalents of a dihalide. So we have Br2, Cl2 are added when we have excess X2. So we see about a 60 to 70% yield and this type of product where all of those X's will represent our halogens. This next reaction, we'll see both with one equivalent of our halogen, one equivalent of X2. We would see both anti and syn addition. So it's noted down here that this mechanism is not completely understood, and if this were an alkene, only the anti-product would be obtained. But we have a major anti-product, and then we also do get a minor syn product as well. So this will be our anti-major, our syn as well. So that's everything from 9.8 that you should note. One equivalent will only give you that one addition versus two excess will give you addition twice. So now we see section 9.9 where we'll focus on ozonolysis reactions. And we should note here that there's going to be a difference with an internal alkyne. So we see cleavage here of this bond using ozone. And something to note is that before we needed dimethyl sulfide or another reducing agent, but we can use water here. And what we'll produce with an internal alkyne would be 2 carboxylic acid. So depending on those R groups, if it was a symmetrical alkyne, these would be the same product, but if there are different R groups, we would see 2 distinct carboxylic acids. Now, if we have a terminal alkyne, we get a different variety of products. All right, so this bond is cleaved here, and on the one side, right, we'll get our carboxylic acid, but from the other side, being treated with ozone, we'll end up generating CO2. So we get a carboxylic acid and carbon dioxide. Again, that's with a terminal alkyne. So what would the product be here? So I had mentioned if we have a symmetric alkyne, we treat it with ozone and water, we would end up with 2 of the same carboxylic acids. So that's what we see here. When that bond was cleaved with this symmetrical alkyne, we can have 2 of the same carboxylic acids. So this can be useful if that's your goal. So that's everything that I wanted to introduce from these 2 sections, and we'll continue with some practice problems for sections 8 and 9 from chapter 9.